Sound is extremely important in animated films because sound helps connect the viewer to what's happening visually in a scene. Take this clip from the animation studio Pixar, for example. Pixar is well known for films such as Toy Story. Here's their intro without sound. Now with sound. You can clearly tell the difference. With sound, it's much more engaging. In the case of that intro, Pixar first created the visuals, and then after that, a sound editor added each sound effect by hand. While this is the commonly used method, in some situations we can speed up this process. Let's take an example of a bouncing ball. If we were to add sounds by hand here, the sound editor would need to sit down and slowly watch the ball bouncing. Every time that it bounces, the sound editor would manually add the sound effect of a ball bouncing on the ground. The sound editor would then estimate how loud the bounce should be and place the sound effect at exactly the right position in the film. This is a simple example because there's only one bouncing ball. Now let's look at a more complicated example. In this example, several pool balls fall onto a surface and bounce off of each other. If the sound editor is adding sound effects by hand, this could take a while. There are numerous objects hitting each other and making sounds. This project automates the process. It detects collisions in a silent animation and adds sound effects automatically. In computer graphics, when we want an object to fall, you might think that an animator would kind of draw an estimate of how the object would move through the air and bounce off the ground. In reality, we run a computer simulation of the object falling. The simulation uses the laws of physics to calculate exactly how an object would fall, bump into other objects, or bounce off the ground in the real world. In our example, we first create a simulation of the pool balls falling. After that, we use new software written for this project to analyze the movement of each ball and figure out where the objects collide with each other in the scene. For each collision, the software adds a collision sound effect. Note that the software doesn't only detect that there is a collision, but determines how hard the collision is, and that tells us how loud the sound effect should be. This is a bouncing ball. Here we can see its graph of height versus time. When it collides with the ground and bounces back up, we see an instant change in direction, from falling to rising. Now, let's look at a graph of speed versus time. We can see an even more noticeable change, where the speed instantly changes. Lastly, let's look at a graph of acceleration versus time. What can we learn from this graph? The spike represents a bounce, and the height of the spike tells us the strength of that bounce, and therefore how loud the sound effect should be. Let's look at the example from before, of pool balls falling onto a surface. This graph shows the acceleration of each ball. Each spike means a collision. The software detects each collision between any two objects. It determines how hard they hit each other, and then places a sound effect into the film at exactly that moment. And the sound effect is at the correct volume. Here are some examples of cubes falling onto a surface.